Hello students, let us proceed further with your factorization more deeply with some extra questions. In the previous class, we have gone through three identities: a plus b whole square, a minus b whole square, and a square minus b square. So, in relation to this, other type of identities are there. So let's do mixing of these three with some other identities also. Let's start with an example. A4 plus B4, A4 minus B4, A4 minus B4. Okay. So in what identity this is falling? You can guess. We have already gone through the identities in which it is falling. Two items are there: a square minus b square, a square minus 2ab plus b square, a square plus 2ab plus b square. So, in which form it is fit? From the first one, definitely there are two terms only. So let's do with first one. So A4 is, whose square will be A4? See, if there is double, then what happened? Multiplication of two exponent and it will be x4. Okay. So which square will be A4? Definitely A square. So a square square minus b square square. This also in similar order: b square square, b square whole square. Okay. Now put the identity here. What is the value of this identity? A plus b into a minus b. That means within bracket, whose square is there, that is a, and whose square is here, that is b. So inside the bracket, it is a and it is b. Here a is a square and b is b square. For next step. Okay. So I am writing a is a square. I am writing a square, but I am talking about a. Okay. A square plus a plus b. This is a, this is b inside bracket. So a plus b into a minus b. Okay. So these are the factors. But again, this factor can be expanded more because it is in this formula directly. So I have to go another step: a square plus b square, a plus b into a minus b. Okay. So this is the factorization of this a4 minus b4. Okay. Let's go with the second number. P4 minus 81. P4 minus 81. So, see, this also fit in the first formula because two terms is there and this can be converted into square and this is also a perfect square. Okay. So whose square will be P4? We have already discussed x4 and a4. So whose square will be P4? P square. Those who are thinking P square, they are right. P square square minus whose square is 81? 9 square. So I have always suggested you to learn by heart from 1 to 20 square value in your mind so that you will solve the problem in very less time. Now put the expression. This is a, this is b. A is p square, b is 9. So a plus b, a minus b. Okay. Now this cannot be converted into an extra form, but this is again comes in this form. This can be converted into more factors because it is also in a square minus b square form. This is p square is square of p, and 9 is square of 3. So I will write p square minus 3 square. Okay. So we can't leave here with p square minus 9 as a factor because it can be converted into more smaller factors. So p square plus 9 into, now write down, this is a is p and b is 3. So a plus b, I am writing a plus b, a minus b. This is the answer. Okay. Let's discuss another example. The third one. Let me see the question. x4 y plus z4. x4 minus y plus z whole 4. Okay. In similar way, this can be converted into square. This can be converted into square. This will be whose square? X square square. Okay, you know it. So this can be converted into x plus z whole square square. Okay. So sorry, y plus z. Y plus z. So this becomes a complex because there are two terms. That's why I have bracket. First I have put first bracket here, and I need another bracket to make its whole square again. Okay. So in which cases, in which situation you need two brackets, you have to decide it. Okay. Now a square, this is a square minus b square, this is b. The whole inside the second bracket is the b. So a is x square and b is y plus z whole square. Okay. Y plus z whole 4, I have converted this one into these two parts, y plus z whole square again to the another whole square because 2 into 2, 4. Okay. A plus b. B is h y plus z whole square. A plus b. Okay. A minus b. Okay. A plus b. Okay. A minus b. Okay. So I have done something wrong here with this more speed. So see this one, what we are doing before was wrong. A plus b, a minus b. So a put it here. What will be the value of y plus z whole square? A plus b whole square. A square plus b square plus 2ab. Okay. I can expand it in this form. In this form, a plus b whole square is there. I have expanded to this form. Okay. Now again x square. Now a square minus b square. Again there is a square minus b square form. See, this is x whole square and y plus z whole square. Okay, y plus z whole square. So it cannot be expanded, but it can be expanded into two more terms, two more factors. Okay, let's proceed. X square plus y square plus z square plus 2yz, and this one a square minus b square. So what I am going to write here, I have done previously here. Okay. So now the same thing is here. What I have explained you, not to forget or not to overconfident. See, a plus b, a is x and y, b is y plus z. So a plus b, it doesn't matter because plus sign is there, but this one A minus B. You must put bracket here. Okay? A plus B into A minus B. A plus B into A minus B. So after minus there is two terms. So I have to put bracket before these two terms. So what is now? This is the final step. Z square plus 2yz. I have just written the same thing here. Now I have to conclude this one. This also. This is also same here. This one x minus y minus z. So some students are doing plus here. So that's why they are losing this step, marking half mark or 1 mark. Okay. Now we proceed another number. That's why p square plus 6p plus 8. P square plus 6p plus 8. Okay. So there are three terms here, but it doesn't seem all are plus sign, but it doesn't seem that it will fall on this identity. It is a square form, but it is not a square form. So to solve this type of problem, how to proceed? See carefully. In this case, in the previous class, what we have come across the question is, there are two squares already present in the question. First one is square and another one, this is a perfect square at that time. But here, it is not a perfect square. Okay? So, if you know, then it will not be a perfect square. So, make it first a square. Make it a square. Now, we are doing this one as 2ab. Let's make it 2ab. How to? I know the value of a, so I am writing 2a. Look at it very carefully. This is the square, a square. I have written 2a into b. Into b. So what I will put here, so that 2ab will be 6p. 2p is already there. If I multiplied 3 here, then it will be 6p. Okay. So I have converted 6p into 2 into p into 3. Okay. So this will be the b term for me in next steps. 2ab. I am making this 6p as 2ab. I know the value of a, and in the formula there is 2a into b. So how much b I have to put to get the 6p here, so that this term will be 6p or 2ab of the identity. So this must be 3. Okay. Now plus 8. So I have got a square plus 2ab. I need another term, that is b square. Okay. So p square plus 2 into a into b. This is b. 2a is p and this is b. So I am adding 3 square. Again subtracting 3 square plus 8. So making this one to convert as a identity of this type, a plus b whole square, I need to add 3 square or 9 to make it a identity form having this factor. Okay. So I need 3 square, b square means 3 square, here b is 3, that's why I need 3 square. So I am adding 3 square, so I cannot just add 3 square, I can add 0 to any term without changing its value. So I am adding 9 minus 9 or 3 square minus 3 square. Okay, plus 8. Plus 8 is from previous step. cannot be omitted, so it is written in the end. Now this comes in this identity. See, a square, 2ab, b square. So from these three terms, I am writing a plus b whole square. Okay. So this one minus 3 square is 9 plus 8. This one I have to write these two terms also. Okay. So now b plus 3 whole square. What is the value of minus 8 plus minus 9 plus 8? Minus 1? Minus 1. So now I can convert this situation into again an identity. Which identity? From these three, one can be converted into square, 1 square. So a square minus b square in this form. Okay. So p plus 3 whole square minus 1 square. See, a square minus b square. Again, second identity is applied here. Now, see, a is p plus 3 and b is 1. A plus b, a minus b. After minus there is single term. So there is no need of putting bracket. So I can write minus 1 directly. There will be no harmful thing for me. So conclude it. P plus 4 into P plus 2. Okay. This is the case. This is the answer. This is the factor of this one. So if there is such type of number question, then proceed in this way to get a perfect solution of two factors, because this is a quadratic equation. So there are two zeros or two factors will be there as answer. Okay. If you could not understand this one, let's proceed with another such type of example. Shall we? Okay. Q square minus 10q plus 21. Q square plus minus 10q plus 21. Let me see. Verify the question once again. Q square minus 10q plus 21. Okay. So this seems like this number. This is not a perfect square. This is a perfect square, but there is no perfect square terms. Two terms needed. Two perfect square terms needed to get this form or this form. Both are, one is minus term, so this it seems to comes under this identity. But it also needs two perfect square form. But there is only one perfect square is there. Q square can be converted to square. So I will proceed in this way. So my next step will be a square. I have to make it 2ab, this one. So 2 minus 2, a is already found. Q, 2ab. B will be how much? So that this 2ab form will be equal to 10q. How to know the value of b? Just divide the 2ab value with the 2a